Right, so let's get started with the division part. Right, so we'll be starting with the calculus. Right. Right, so as you people are aware, in calculus, we are having three topics. So the first topic is about limits and continuity. And the second topic is about derivatives. And the third topic is about integrals. Right. So in limits and continuity, we'll be learning about indeterminate forms. Indeterminate forms 1, 2, and 3. And of course, we'll be going with the continuity also. And coming to the derivatives. So in derivatives, we'll be learning about how do we differentiate, and two types of derivatives. One is the ordinary derivative, and another one we'll be calling it as the partial derivatives. And we'll be learning about the applications of the derivatives. And in applications, we'll be learning about maxima and minima in 1, 2, and 3 variables. And we'll be learning about Taylor series. And when it comes to the integrals, so in integrals, we'll be learning about I didn't get it, Joshi, what you are saying through time application. I won't think it is time application. I think you have to log in with the Zoom. I think today is the recording, or the class is scheduled in Zoom meeting. Is it with everyone, or with only Joshi? Right. Right. So when it comes to the integrals, we'll be learning about definite integrals. Uh, yeah, good evening, Srikar Raj. This is the first slide that I'm discussing.
Okay, sir.
Right.
Good evening, sir.
Yeah, good evening. So we'll be learning about definite integrals, and we'll learn about multiple integrals. And in multiple integrals, we'll be learning about double integrals and triple integrals. And we'll be learning about some applications. And in applications, we'll be studying about area bounded, volume enclosed, and change of order, and change of variables. Right. So these are the topics what you are having in calculus. Now, let me ask you people, I think by this time you should have finished the complete syllabus. And as it is only the revision class, or have you started now? Yeah?
Excuse me, sir, I didn't understood what you asked for now.
Now, I asked you, have you completed your syllabus and everything? And now you are starting with the revision. Like, what are the topics?
Actually, sir, I have missed some classes of engineering maths. And when
Okay.
it comes to completing syllabus, sir, what I have done,
Mhm.
sir, what I have learned in the live classes as well as on my own, means
Mhm.
I also studied this maths on my own.
Okay.
In that way, I have completed the syllabus, but I am not sure how much I have completed, whether I have completed fully or anything is remaining.
Right.
Sir, some topics are remaining, sir. It is related to numerical integration,
Mhm.
um, Fourier series,
Okay.
and sir, in differential equations, I have some doubts,
Okay.
and I think very few topics are remaining different in differential equations as well as linear algebra and calculus.
Okay. May I know from which branch you are, Srikar?
Mechanical.
Mechanical. Okay, then. Right. And someone has just texted check rank. Some important topics for the exam.
Yes,
Okay.
sir.
Right. Okay, then. So just let me, what we'll do is we have been given 4 days. That means 4 sessions. So in 4 sessions, what I'll do is I'll revise each and every topic, not the problematic, okay, about the conceptual wise. And we'll be discussing about previously asked gate questions as per the topic wise. I think that would be better. Like you'll be getting an idea how the questions will be asked in the gate. Will that be okay with everyone, or do you want me to go in a different way? All
Uh,
right. Yes, Srikar, go ahead.
Sir, you can go as you want.
Okay, then. Right. So just let me write all the topics what we are going to study, okay, and what we are having in it. Now, when it comes to the first topic, that is the limits. So if you are from civil and mechanical, you can definitely, and of course from CSC also, you can definitely expect a question on limits. Civil, mechanical, and CSC. Okay. Right. So now I don't want to dig into the definition of the limit. So just let me go directly what a limit means. So we'll be writing a limit as limit extending to a, f of x is equals to L. And we'll be saying the limit exists if and only if the left limit. So that means the limit exists if and only if the left limit is equals to the right limit. That means limit extending to a minus f of x should be equals to limit extending to a plus f of x. right? And we'll be calling this limit value as what? We'll call this limit value as expected value, right? And if you have attended the classes of mine on calculus, I said we'll be discussing mainly about few functions, and they'll be till the end of what we say, till the end of the calculus. And we have discussed, like when we talk about a function f of x is equals to mod x minus a, for this function limit exists at every point. And again, when we talk about a function f of x is equals to mod x minus a upon x minus a, for this limit exists at every point except at x is equals to a. And when we talk about the bracket function, which is also called as the step function, f of x is equals to bracket x. For this, we'll be saying limit exists at every point, except at integers. And when we talk about this first type of form, that is indeterminate form 1, so what this indeterminate form 1 says? Can anyone? What is this indeterminate form says? Right, perfect, Balaji. So that means if limit extending to a, f of x by g of x, if it is of the form 0 by 0 or infinity by infinity, okay, so then what we'll do? We'll apply L'Hospital's rule. Apply L'Hospital's rule. Now, what is this L'Hospital's rule says? Differentiate the numerator separately and the denominator separately, right? And based on this, we have evaluated few integral or few limit functions. Like when we talk about limit extending to 0, sine ax by x, how much? Uh, right, I think Balaji has answered correctly. It is a. And in the same way, limit extending to 0, e to the power ax minus 1 by x, and which is again a. And limit extending to 0, tan ax by x, which is a. And one more, which was asked for civil, limit extending to infinity, sine ax by x, which is always 0. Okay. Right. So these are the direct limit values. Okay. And now when we talk about indeterminate form 2, so what is this indeterminate form 2 says? That is, if limit, right, perfect. If limit extending to a, f of x into g of x, if it is 0 into infinity form, okay? So then what we'll do is, we'll write either f of x to the denominator or g of x to the denominator, so that it will convert into the form 0 by 0 or infinity by infinity, so that we can apply this L'Hospital's rule. And so every time, which term to bring it down? So we'll follow this Eilate rule, where I stands for inverse trigonometric, L stands for logarithmic, A stands for algebraic, T stands for trigonometric, and E stands for exponential. Now from the bottom, whichever function comes first, we have to bring it to the denominator. So like say if I am having x into e to the power minus x. So first exponential is coming, so I'll bring the exponential term to the denominator. And then I'll apply this L'Hospital's rule. So according to Eilate rule, whichever comes first, we'll bring it to the denominator. And then when we talk about this indeterminate form 3, so this indeterminate form 3 will talk about limit extending to a whenever we are dealing with the powers. That means f of x to the power g of x. And if it is 0 to the power 0, or it is 1 to the power infinity, or it is infinity to the power 0, okay? So then generally what we'll be doing here is, we'll bring, in order to bring the power term down, we'll apply log on both sides. So we'll take y is equals to f of x to the power g of x, and then I'll apply log. So that means limit extending to a, log y is equals to limit extending to a, g of x into log of f of x. Now, there is no doubt that it will become in the form of 0 into infinity. Okay. So then according to Eilate rule, so we'll bring the term down. I think as log is coming at the last, so we have to bring g of x to the denominator and then apply L'Hospital's rule. So we'll be getting the limit value of log y. But I want the limit value of y. So then if I bring log to the right side, so then it will become e to the power limit extending to a, g of x into log of f of x. Okay, and this is how we'll be finding the limit if it is in indeterminate form 3. And remember, if I'm having limit extending to a, f of x to the power g of x, if the limit value is in the form of 1 to the power infinity, then what we'll do is we'll take e to the power limit extending to a, g of x into f of x minus 1. So directly you can do it this. Okay. Now, like say for example, if I'm having limit extending to infinity 1 plus a by x to the power x. Now, if we apply the limit, so then it will be of the form 1 to the power infinity. So then, what is the formula? That is e to the power limit extending to infinity g of x. So that is x into f of x. So 1 plus a by x minus 1. So plus 1 minus 1, x will be going one time and we are left with only a. So that is e to the power a. And in 2019, a question was asked, not 19, in 2020, a question was asked for civil. Like the question was asked like the value of 1 plus 1 by infinity to the power infinity. And it was asked in a fill in the blank. Okay. So now, how do we solve this? So that will be equals to, so we can write this as limit extending to infinity 1 plus 1 upon x to the power x. Right? So if I substitute x equals to infinity, so then it will be of the same form. So then that is equals to how much? So that is equals to e to the power 1. And e to the power 1 means it is e. Okay, so this question was asked in the fill in the blank for civil. And remember, when we talk about this limit extending to infinity, 1 plus a by x to the power x is same as limit extending to infinity 1 plus 1 by x to the power ax. And they both are equals to e to the power a. And again, limit extending to 0, 1 plus ax to the power 1 by x. And that is same as limit extending to 0, 1 plus x to the power a by x. And they both are equals to e to the power a. And limit extending to 0 or infinity, 1 plus a by x to the power bx. That is same as limit extending to 0, 1 plus ax to the power b by x, and they both are equals to e to the power ab. Okay. So these are the direct formulae that to be remembered when, or you can say it is a quick reference for your gate exam. Like when you are going for your gate exam, if you just have a look at all these things, okay, so you can directly remember this formulae when you are going for the gate exam. So that means limit extending to 0 sine ax by x is a, e power ax minus 1 by x equals to a. Now we'll solve the problems which are related to all these direct forms. And if we are getting 0 into infinity, how do we convert them? And if we are getting 1 to the power infinity, how do we convert all these things? And whenever we are dealing with the powers, okay, like 1 to the power infinity or 0 to infinity to the power 0 or 0 to the power 0, okay. So these are the direct formulae that to be remembered, right. Now, when it comes to the continuity, now we'll be saying a function is continuous at a point x is equals to a if limit extending to a f of x. So that means if the expected value is equals to the function value. And we call this limit value as what? We'll be calling it as the expected. And we'll be calling the function value at a point as observed value. So if the expected value is equals to the observed value at a given point, then we say the function is continuous at a point. And again, like when do we say a function is having a limit? So that means if limit extending to a minus f of x is equals to limit extending to a plus f of x, and they both should be equals to f of a. And if the left limit is equals to the function value. Sure, Shibani. After that's what I'm preparing the notes. Like just for you, a quick revision, and as well as you people can have a look at what you are doing. Okay, or you can say a quick revision for you, a short notes. In other words, right? Okay. Now can you see? I've switched off my video. Srikar Raj,
Yes, sir.
can you see the screen now? I've
Yeah,
switched
now
off.
I can see. Yeah, I can see the screen now, but but the logo of Time Chennai is
Okay,
visible, sir.
okay. Right. So if the left limit is equals to the function value, then we say it is left continuous. And if the right limit is equals to the function value, then we say it is right continuous. And we say a function is continuous if and only if it is both left and as well as right continuous. And again, whenever in order to check out whether a function is continuous or not at any given point, okay, so directly whenever a function is of the form, that means uh, let us say f of x is equals to h of x by g of x. So whenever we are having a function of the form f of x by g of x, so directly we can say this function is not continuous at g of x is equals to 0. So for all the values of x for which the denominator is becoming 0, then we say the function is not continuous at that point. And again, when it comes to the types of discontinuous, now when we talk about if the limit exists, but if it is not equals to the function value, then such type of discontinuity, we call it as removable discontinuity. And if limit itself is not existing, so if limit itself is not existing, then such type of discontinuities will be calling them as jump discontinuity. Okay. Now, if we look into the examples, like the one which we have already discussed about the limit. Now, when we say f of x is equals to mod x minus a by x minus a is continuous at every point, but or except at x is equals to a. And when we talk about f of x is equals to mod x minus a, so is continuous at every point. And when we talk about f of x is equals to step x, so this function is continuous at every point except at integers. So this mod x minus a by x minus a and bracket x, these both functions are having jump discontinuities at a and at integers. Okay. Right. Now let's see some of the problems which were asked in GATE. and how to solve them. Now let us say if I am having limit extending to 0, 1 minus cos of x square by 2x to the power 4. Now if we apply the limit, so what we are getting? Cos 0 is 1. So 1 minus 1, that is 0 by 0. So we are getting in 0 by 0 form. So then it is in indeterminate form 1. Now if it is in indeterminate form 1, what did I tell you? Apply L'Hospital's rule. So derivative of cos, so that is minus sine. So it will be positive sine of x square into inner term derivative, that is 2x upon 8x cube, right? So now 2x will be going how many times? It will be going 4x square times. And if you look into the properties of the limit, I said limit extending to 0 sine ax by x is a, right? So that means here limit extending to 0 sine of x square by x square, this limit value is what? This limit value is 1. So then the value of the limit is how much? 1 upon 4. That's it. It's a straight away one. Right, perfect. Now again, in the same way, if we apply the limit over here, so what do we get? So log 1, so it is 0. E part 0, that is 1. 1 minus 1, which is 0. So again, we are getting 0 by 0 form. So apply L'Hospital's rule. That is limit extending to 0. Derivative of log, it is 1 upon 1 plus 4x into the inner term derivative, that is 4, upon derivative of e power 3x, 3 e power 3x. And if we apply the limit, so what we are getting? 4 upon 1 plus 0 upon 3 times of e power 0. And the value of the limit is how much? It is 4 upon 3. Now, so here is a question which was asked in GATE 2022 for computer science. So if we apply the limit, so what we are getting? We are getting 0 by 0, right? So if we are getting 0 by 0, so now apply L'Hospital's rule. So that is limit extending to 0. Derivative of root, it is 1 upon 2 root upon derivative of or minus derivative of e to the power 2 root x into the inner term derivative. That means derivative of 2 root x. So 2 times of 1 by 2 root x. So 1 by 2 root x, 1 by 2 root x will get cancelled. And that is equals to, if we apply the limit, that is 1 upon or negative 1 upon 2 times of e power 0, right? And that is equals to negative 1 upon 2, which is negative 0.5. Right? Okay. Now again, if f of x is equals to root of g of x minus 1 upon root over x minus 1 for x not equals to 1 and 1 for x equals to 1. And the values of g dash and g at x equals to 1 are given to be 2 and 1 respectively, then the value of the limit at x tending to 1 f of x. So now we'll check out the limit extending to 1 root over g of x minus 1 upon root x minus 1. Now if we apply the limit, so g of 1 is how much? That is 1. Root over 1, 1. 1 minus 1, that is 0 by 0. So we are getting 0 by 0 form, right? Now when we are getting 0 by 0 form, so we have to apply L'Hospital's rule, that is limit extending to 1, derivative of root, 1 by 2 root g of x into the derivative of g of x. So that is g dash of x upon derivative of root 1 by 2 root x. Now, if we apply the limit, so what we are getting? 1 upon 2 times of root over g of 1 into g dash of 1 upon 1 upon 2 root 1. So 1 upon 2, 1 upon 2 will get cancelled. Now what is g dash of 1? That is 2 upon 1. And the value of the limit is 2. Right. Now here is the one which was asked in 2022 for mechanical. So if the value of p, that is limit extending to pi, x square plus ax plus 2 pi square upon x minus pi plus 2 sin x has a finite value alpha. The value of a and the corresponding value of p is. Right. Now, if we apply the limit, so first if we are applying the limit, so what is the function that we are having? That is x square plus ax plus 2 pi square upon x minus pi plus 2 sin x. So if we are applying the limit, so what we are getting? That is pi square plus a pi plus 2 pi square upon pi minus pi plus 2 sin pi. Right? A. Right. Perfect, Vikram. Right then. So here, what is happening? This is 3 pi square plus a pi upon we are getting 0. So anything by 0 is not defined, but the value of the limit is finite. Now, when the value of a limit is finite, but here we are getting infinite, so it purely depends upon the value of a. So as the denominator is 0, in order to apply L'Hospital's rule, what we are supposed to do? The numerator also should be 0. That implies 3 pi square plus a pi should be equal to 0. That implies the value of a is negative 3 pi, right? So I got the value of a as negative 3 pi. Now check out for which value we are having negative a value as negative 3 pi, the first one. And for the second, it is negative 2 pi. For the third, it is pi. And for the fourth, it is 2 pi. So only one option is there with the value of a as negative 3 pi. So you can go with option A. Right? So this is how the questions in the limits will be asked. Right. So this is about the limits. Now let's look into the derivative concepts. Right.
Excuse me, sir.
Yeah. Yes, Srikar.
Yeah, in the recent slide, that how that above numerator equal to 0, so it means that 3 pi square plus a pi
Okay.
equal to 0.
Yeah. Now, if the numerator is not equal to 0, let us assume if the numerator is not equals to 0, then what will be the limit value? It is infinite. Yes or no?
Okay, sir.
But the value of the limit is given as finite. Okay.
Yes, sir.
So when the value of the limit is finite, then obviously it has to be in 0 by 0 form. Okay.
Means if the alpha is infinite, a is in that finite value, sir, then its
Yeah.
limit should be 0.
Yes. That means it should be 0 by 0. It has a value. The limit is having a value. And the limit value is pi.
Okay, sir.
Right. Now, when it comes to the derivatives, so we'll define the derivative in two different ways. Coming to the definition of the derivative, so first form, we'll be calling it as it is the rate of change of dependent variable, rate of change of dependent variable with respect to one or more than one or more than one independent variable. And another way of defining the derivative is a function f of x is differentiable at a point x is equals to a if limit extending to a f of x minus f of a by x minus a, if this limit exists. Or it is also written as limit h tending to 0 f of a plus h minus f of a by h, if this limit value exists. Or it is also known as, it is the slope of tangent to the curve, slope of tangent to the curve y is equals to f of x at a point x is equals to a. Okay, and that will be denoting it as dy by dx at x is equals to a, or even we can denote it as f dash of a and so on. Okay, now depending upon coming to the first definition, depending upon this number of independent variables, the derivatives are again classified into two categories. One will be calling it as the ordinary derivative, and another one will be calling it as the partial derivative. Okay. Now, when it comes to the ordinary derivative, it is the change with respect to only one independent variable. With respect to only one independent variable. So that we'll be calling it as the ordinary. And when it comes to the partial, the change is with respect to more than one independent variable. More than one independent variable. And we'll be denoting it as dou f by dou x or dou f by dou y. Like say if I'm taking a function f is a function in two independent variables x and y, or you can even write it as dou square f by dou x dou y and so on. Okay, and seriously, if you are from EC and electrical, you can expect a question on partial derivatives. Okay, now I think you people might be aware how to do this partial derivatives and all, but anyhow, let me write few note points on this partial derivatives. Even in 2023 and 2024, there was a question on partial derivatives. So when we talk about this partial derivative, like say if I'm having a function, say if we have a function f in two independent variables x and y, and if I'm writing dou f by dou x, so that means what? We are differentiating f partially with respect to x, partially with respect to x, treating y as constant. So we have to differentiate only x, and all the remaining variables are treated as constants. And in the same way, dou f by dou y is differentiating f partially with respect to y, treating x as constant. And again, when we talk about a homogeneous function, like say, if u is equals to f of x comma y is a homogeneous function of degree n, say if it is a homogeneous function of degree n, then x into dou u by dou x plus y into dou u by dou y. Can anyone tell me that is equals to how much? That is equals to n into u. So this we'll be calling it as what? We'll be calling it as Euler's formula. And in the same way, if we talk about the double derivatives, x square into dou square u by dou x square plus 2xy into dou square u by dou x dou y plus y square into dou square u by dou y square, and that is equals to n into n minus 1 into u. Right, perfect, Farin. Now this is a homogeneous function. Now, like say, if I'm having, say if u right, I'll try to see I'll try to write towards right side, Srikar. Okay, right. Now, let us say if u is equals to a function of xy is not homogeneous, but f inverse of u, like say that is g of u, is homogeneous, then x into dou u by dou x plus y into dou u by dou y is equals to n into g of u by g dash of u. Like say, for example, if I'm having a function, say u is equals to tan inverse of x cube plus y cube by x minus y is there. So x cube plus y cube by x minus y is homogeneous, but tan inverse of that is not homogeneous, right? So this is not a homogeneous, but if I'm bringing tan inverse towards left, that implies what? Tan of u, which is x cube plus y cube by x minus y. This function is a homogeneous function of degree how much? of degree 2. Right. So then x into dou u by dou x plus y into dou u by dou y is given by what? N into g of u by g dash of u. That means n is 2, g of u is tan u, by derivative of tan, that is secant square u. So this is how the modified Euler's formula is applied. Okay? Right. Now again, when we talk about the partial derivatives, say if I'm having a function u is equals to f of x, y, and z. Okay, right, Vikram? Right. Now let us say if I'm having a function f is equals to x square plus xy plus y square. Now, what is the degree of each and every term? Yeah. What is the degree of each and every term? So the degree of each and every term is 2. So then we say it is a homogeneous function of degree 2. Now, in the same way, if I am having f is equals to x cube minus y cube upon x square plus y square is there. Now, first question, is it a homogeneous? Now, when you look into the numerator, numerator is a homogeneous of degree 3 and the denominator is a homogeneous of degree 2, right? So then f is a homogeneous of degree how much? X to the power m by x to the power n is x to the power m minus n. That means 3 minus 2. Degree is 1. So it is a homogeneous of degree 1, right? So in the same way, if we look into this example, x cube plus y cube by x minus y is a homogeneous. Numerator is of degree 2 and the denominator is of degree 1. So then tan u, which is g of u, is a homogeneous of, 3, is a homogeneous of degree how much? 3 minus 1, which is 2. Understood, Vikram, about the degree? Right. Right then. So, in differential equations, that is different. When we talk about the degree, we have to look at the order of the derivative. Here we are saying homogeneous function we are saying. Okay. Homogeneous function is different and degree of a homogeneous is different and degree of a differential equation is different. They both are different. Okay. Right. Now again, let us say if u is equals to f of xyz is any function in 3 variables, then the total derivative of u is given by dou f by dou x dx plus dou f by dou y dy plus dou f by dou z dz. So this we'll be calling it as the total derivative of a function. Like say, for example, if I'm having a u is equals to x square y. So the total derivative of u is given by dou u by dou x dx plus dou u by dou y dy. And what is partial derivative of u with respect to x? So that means I have to differentiate only x terms. So that means derivative of x squared, that is 2x. Y is treated as constant dx plus x square dy. So this we'll be calling it as like I didn't get it, Srikar. Degrees means degree of a differential equation or a degree of a homogeneous function.
Sir, I think it's related to degree of homogeneous function. only. Just now I told something homogeneous degrees are like this, non-homogeneous. Just after writing this f of x, f equal to x cube minus y cube, the whole divided by x square plus y square.
Yeah.
Just after it, you have told.
X to the power m by x to the power n is how much? X to the power m minus n, right?
Yes, sir.
So degree of numerator is 3, degree of denominator is 2. Then the degree of the whole function will be 3 minus 2. Okay? Right.
Okay, sir.
So this is the total derivative of a function. Now, here let us say u is a function in 3 variables. And if all these 3 variables are functions of 2 more variables, like say, if I'm having u is a function in 2 variables, say x and y, and x is a function in 2 variables r and s, and y is also a function in r and s. Now, if I want to find dou u by dou r, so dou u by dou r is given by dou f by dou r, sorry, dou f by dou x into dou x by dou r plus dou f by dou y into dou y by dou r. And in the same way, if I want to find dou u by dou s, then that is dou f by dou x into dou x by dou s plus dou f by dou y into dou y by dou s. And this we call it as the chain rule. We'll be calling it as the chain rule of the derivatives. Okay. So this is all about your partial derivatives and related, what you say, related formulae which are with the homogeneous function. And let me write the name here. So we'll be calling it as Euler's formula. Right. Okay. And this we call it as the extended Euler's formula. Right. So these are all the formulae which are related with the partial derivatives. Okay. Now let's go with no, Srikar, like can't you see it from here? Like from here, dou u by dou s is equals to dou f by dou x
Sir,
into dou
not.
x by dou s.
Excuse me, sir, not this slide, sir. Present slide. In the previous slide, where it is being written Euler's formula something.
Yeah. I know that.
You know
So
that
as you
Euler's
said,
formula.
yeah, as you mentioned, that's the reason I have left so much of blank here. Okay. So nothing to worry, Srikar. I'll be sharing all these slides with you. Okay. At the end of the session, all the slides will be shared with you, and even you'll be having the access for the videos. Okay. So I have
Sir,
kept
how
it
can
in
I
a
have
recording.
access for videos?
Sorry.
How can I have access for videos? Means.
So the time management or the time people have recorded in the cloud. I'm recording in the cloud. They'll be sharing the cloud link with you so that you can have the access. Okay, Shrikar?
Yeah, okay, sir.
Right. Right. So this is about your partial derivatives and all. Now let's talk about maxima and minima. Coming to the application part. Maxima and minima in one variable. So what is the working rule for finding maxima and minima in one variable? Now first what we'll do is we'll find f of x. Okay. So first step, I'll find x for f dash of x is equals to 0. That means first I'll find out the derivative and I'll equate it to 0. And I'll check out for what value of x that double derivative is 0. And let us say that point, say the point is x is equals to a. Okay. Now again at that particular point, so this point x is equals to a, we'll be calling it as stationary point. Okay, so we'll be calling it as the stationary point. Now after getting the stationary point, we'll find the double derivative. That means if f double dash of a, if it is less than 0, then we say the function f has maximum value at the point x is equals to a. Okay. And again, if f double dash of a, if it is greater than 0, then f has minimum value at the point x is equals to a. And if it is equal to 0, that means if f triple dash of a, if it is equals to 0, then we say the function has neither max nor min. Neither max nor min. And again, if f triple dash of, sorry, here it is double derivative. And if f triple dash of a is not equal to 0, then x is equals to a, we'll be calling it as point of inflection. And remember this word, for mechanical, on this point of inflection, he asked a question 3 times. Yeah, saddle point will be calling in 2 variables. Saddle point is in 2 variables. And here in one variable, we'll be calling it as point of inflection. Okay, right. So now when it comes to maxima and minima in 2 variables, sorry, in one variable, there are 2 kinds of maximas and minimas. Like say for a given function f of x, it can have max and it can have min. And this max is of 2 categories. One, we call it as local max, and another one we'll be calling it as global max. And in the same way, when it comes to minimum, again this minimum are of 2 types. One is local min, which is also called as the relative min, and another one we'll be calling it as global min. And in other words, it is also called as absolute min. Okay, right. So now this is about your local max and local min, global max and global min. Now again the question, sir, when do we look at this local max and local min? So whatever the working rule that we have written here, So finding out the maxima and minima in this way, you'll be getting the local max or the local min. And we talk about this global max and global min only when we are given a region. That means whenever an interval is given to us, we are supposed to find the local max, or sorry, we are supposed to find the global max and global min. Now, when we are talking about this global max and global min, what we'll do is we'll find. So find x for f dash of x is equals to 0. And let us say the point is x is equals to c. Now, at these points, that means at x is equals to a, at x is equals to c, and at x is equals to b, I'll find the values of the function f of a, f of c, and f of b. Now, among these three, whichever is max, that we call it as the global max. And among these three, whichever is min, that we'll be calling it as the global min. Okay. So this is about, and remember, if the interval is given to us, by default or automatically, it is understood that we are supposed to find the global max and global min. Then no need of checking out the double derivative. So if the interval is given, directly this will be your working rule. If the interval is not given, then this is the working rule. So this is a working rule for local max or min, or local max and min. And this is the working rule for the interval is given to us. So whenever the interval is given to us, we are supposed to find in this way. Okay, right. Now again, so this is about maxima and minima in one variable. Now let's see maxima and minima in two variables. And in a very
Excuse
rarest
me, sir.
case, yeah.
Sir, in the recent slide, sir, when intervals are given, in what way we have to find, sir? This down right one or the top one, sir?
When the interval is given, the down.
This below here, I have to find x for f dash of x equal to 0 by taking x as c. I have to do this thing when interval is given, sir.
Yeah, let's talk about this. As in 2020 for EC, f of x is equals to 8 log x to the base e minus x square plus 3 as minimum over the interval 1 comma e. Then the value of x. Now here, what did he give? He gave us the interval. Now when the interval is given, by default, it is global max or global min. Now what is f of x that we are having? F of x is 8 log x to the base e minus x square plus 3. Now I'll find out f dash of x, that is 8. Derivative of log is 1 by x minus 2x. And I'll equate it to 0. So then what do we get? 2x cube is equals to 8. That means x is equals to 2. Now find out the value of a function at x equal to 1, at x equal to 2, and at x equals to e. So as the interval is given, we are supposed to find the global max or global min. So here he is talking about minimum. So f of 1. So what is f of 1? Log 1 is 0. It is minus 1 plus 3, which is 2. And f of which point? 2. What is f of 2? That is 8 log 2 minus 4 plus 3. And that value is around 4.5. and f of e log e is 1, 8 minus e square plus 3. And that is 11 minus e square, that is 3.6. So among these three values, which one is minimum? 2 is the minimum, right? So 2 is the minimum. At which point we are getting? At x equal to 1 we are getting. So he didn't ask what is the minimum value. He asked at which value of x. Yeah, Farhin, that is the main thing. Okay, so we are supposed to find the value of x for which the function is having minimum value. At which point it is having the minimum value? At x is equals to 1. So at x is equals to 1, the function is having minimum value. He didn't ask the minimum value here. Okay. He asked at which point it is having the minimum value. You see, all the answers are in the options. We are having E, we are having 2, which is the minimum value. We are having 1 at that point. So you have to be very careful in identifying what he is asking and at which point you are supposed to find. Right? Right, Srikar. I hope your doubt is clarified.
Sir, what you have told I didn't understand, sir. But okay, sir. In this question, sir, I have to find minimum value. So I have given some equation f of x. It has some minimum value over 1 comma e. Then I have to find the value of x here, sir. First, what I would do, sir, I need to do differentiation. First thing is the differentiation of f of x. Second step is, sir, I have to substitute x value like 1, 2, etc., sir. Finally, sir, I have a doubt regarding the second part. Sir. If I get this type of question, sir, I need to take x equal to 1, x equal to 2 like this. But then also, if I don't get my answer, I need to take x equal to 3, 4 up to a number like 100.
No. That is what the working rule I have given. What the working rule said here, I have to find the value of x for which f dash of x equal to 0. Let us say that point is x is equals to c. Right? Now, I have to find the value of the function with only these 3 points in that interval. That means a, b, and the point for which f dash of x equal to 0. Did you get it now?
I
So
have to
among
find
these
that value.
yeah,
I have
among
to find
these
that value
three,
for this.
yeah, among these three, whichever is the minimum value or whichever is the least value, that is your minimum. Did you get it, Srikar?
So whichever is the least value will become my minimum value.
Yeah, that's it. Now here, in this example, you see.
Okay, sir. I have to find the value for which for which I will get minimum value. Means I have to find that value for which f dash of x will be 0.
First, you have to find the stationary point, and then you have to find the value of the function at the end points. What are the endpoints? 1 and e. Okay. So I have to find the value of a function at 1 and at e and as well as at the stationary point. Only at these 3 points you are supposed to check the value of a function. Okay.
हेलो सर.
Yeah.
ये सर ये x का वैल्यू तो सर मतलब कि अब इसमें 2 आया है सर, वो 3 भी हो सकता है, 4 भी हो सकता है, मतलब x का जितना वैल्यू आएगा उस पे पुट करना है सर वैल्यू को.
हाँ, उसके अंदर ही पुट करना है,
और
लेकिन
जो वो गिवन जो दिया हुआ है, फिर उसमें मतलब जो स्टेशनरी पॉइंट आएगा एक्स का, उसका लेना है हमें, और जो उसने गिवन दिया है 2 या 3 वैल्यू, उसका लेके उसमें से फिर मिनिमम या मैक्सिमम करना है।
हाँ, लेकिन और एक बात भी आप ध्यान में रखना कि ये एक्स का वैल्यू, ये स्टेशनरी का वैल्यू, ये इंटरवल के अंदर है या नहीं, वो भी देखना है आपको।
तो सर वो तो फिर अगर उसमें कुछ सर वो ऑब्सेशन लगा देगा कि ग्रेटर देन या इक्वल टू वाला सर, तब ना ये चीज करेंगे सर। अगर वह यहाँ पे सर जैसे क्वेश्चन में 1 और ई दिया हुआ है और मेरा स्टेशनरी पॉइंट x इज इक्वल टू 2 3 4 आ रहा है सर, तो इसमें तो हम ले सकते हैं। पर
हाँ,
अगर वो अगर दे दिया कि 1 इज ग्रेटर देन x इज ग्रेटर देन इक्वल टू 1 और 4 के बीच में अगर अराउंड कर रहा है, अगर 5 मेरा x पॉइंट आ रहा है तो हम 5 नहीं लेंगे, लेकिन 1 से लेके 4 तक लेंगे। ओके सर?
हाँ। अब देखिए, जो आप बोले इंटरवल मुझे 1 to 4 तक दिया हुआ, ठीक है,
यस
इंटरवल
सर।
मुझे 1 to 4 तक दिया हुआ है, लेकिन मुझे स्टेशनरी पॉइंट्स एक -3 आया, और एक 0 आया, और एक 2 आया, और एक 5 आया, ठीक है। अब
यस
मैं
सर।
फंक्शन का वैल्यू कौन से पॉइंट्स का ने चेक करना, 1 का ने चेक करना, ठीक है। 3 ये इंटरवल के अंदर है, ये इंटरवल के अंदर 3 नहीं है, तो मैं
नहीं
3,
सर, -3 नहीं है।
-3 नहीं है, सो -3 को मैं निकाल दूंगा। 0
बस
ये
सिर्फ सर।
इंटरवल के अंदर है, ये भी
नो
नहीं
सर।
है, एंड 2 ये इंटरवल के अंदर है,
यस सर।
सो 2 का मैं चेक करूंगा। 5 ये इंटरवल के अंदर है,
नो
नहीं
सर।
है, सो और ये 4 का ने भी चेक करना मैं फंक्शन का वैल्यू। अब
थैंक यू सर।
या अब इनमें से among these whichever is the minimum, that is your global minimum, and whichever is the maximum, that is your global maximum. Got it, Srikar?
Sir, whatever has been discussed, again, I didn't understand why x equal to why 1 is the answer for this question, sir. Because the thing is, sir, we need to get f dash of x equal to 0, sir. Means, sir, if I take 1 here, I will get I need to get 0, sir. But the point is, sir, if I take x equal to 1, f of 1 is -1 plus 3 equal to 2, sir. This is
Mm-hmm.
let us take this as minimum value, sir. Then how
Mm-hmm.
x equal to 1 here?
You look at the question carefully. The function has minimum value in that interval. Okay?
Okay,
The
sir.
function has minimum value in this interval.
Hmm.
At which value of x is asking? At which point it is having the minimum value? That is what the question is, Srikar.
Okay, sir. At which point the minimum value is there?
Yeah,
Okay, sir.
right.
Uh, Minimum value means so here. Okay. When I took x equal to 1, I got 2, sir. When I took x as 2,
Mm,
8 ln 2 minus 4 plus 3. If I
mm,
8 ln 2 is something value, 8
mm.
ln 2 minus 4 plus 3 is not 2, so it is more than 2, something like
Yeah,
4
4.5.
minus 4 into 5, 20,
Mm,
4.5.
mm.
Okay, sir. If I compare this, 2 is the minimum value, and it is obtained when I took x equal to 1. So
Yes.
therefore, 1 is my correct answer.
Yeah,
Okay, sir.
right, Srikar. Okay, then. So this is about, okay, let's solve one more here. Why only to go with one or two? I think I have taken one more question also for this. It is not there here. Okay, I'll write down. So first, let's discuss about the working rules of all these things, and then we'll discuss about the problems, right? So now coming to your maxima and minima in 3 variables or 2 variables. Okay. Max and min in 2 variables. So when we talk about max and min in 2 variables, so as 2 variables, let us say the function is x and y. So we have to go with the same working rule. So first I'll find dou f by dou x, dou f by dou y, and equate both to zeros. That means what? Dou f by dou x is equals to 0. Dou f by dou y is equals to 0. Now solve these two equations. Solve the equations for x and y. And let us say the point is a comma b. And this point we call it as what? We'll be calling it as the stationary point. Now after getting the stationary point, we'll go with the double derivatives. So what are the double derivatives? Denoted by r, that is dou square f by dou x square, s, that is dou square f by dou x dou y, and t, which is dou square f by dou y square. And also find rt minus s square at these stationary points. So after getting all these things, now we'll write down the conclusions. So what are these conclusions? If rt minus s square, if it is greater than 0 and r is greater than 0. Now when the double derivative is greater, then f has which value? F has minimum. At which point? At a point 0 a comma b. And in the same way, if rt minus s square is greater than 0 and r is less than 0, then f has maximum at a comma b. And if rt minus s square, if it is less than 0, then neither max nor min. And this point, we call it as what? Yeah, Farin, you were just asking, right? Perfect. You have already written. So we call the point a comma b as saddle points. And if rt minus s square is equal to 0, then no conclusion can be drawn. Okay, right. So this is about your maxima and minima at in 2 variables. Now when we talk about maxima and minima in 3 variables, right. This is a bit complicated, I can say. And to be frank, hardly 2 times a question was asked in 2 variables, maxima and minima in 2 variables. One is in 2014 and another one is in 2015 for EC and electrical. For both of them, a question was asked in 2 variables, which can be solvable in 3 variables. And again, that can be solvable in 1 variable. Okay, so that questions, you can solve it in all the 3 forms. Now, we'll discuss about that problems also. Now, when we talk about the working rule, now let us say we'll put a condition for maxima and minima in 3 variables. Like say we have a function in 3 variables subjected to, that means these variables are following a relation, or the relation between these 3 variables should be given. Now let us say this is equation 1 and say this is 2. So now first we'll find the Lagrange's function, that is f, which is given by f plus lambda phi. So we call this as Lagrange's function. And after getting this Lagrange's function, we'll find dou f by dou x is equals to 0, dou f by dou y equals to 0, and dou f by dou z is equals to 0. And then we'll solve, let us say, these 3 equations together as equation 3. Solve 2 and 3 for x, y, and z, and upon substituting in 1, we get required max or min. So this is the working rule for maxima and minima in 3 variables. Now this equation 3 can also be written as minus dou f by dou x upon dou phi by dou x is equals to minus dou f by dou y upon dou phi by dou y is equals to minus dou f by dou z upon dou phi by dou z. So equation 3, instead of equating to 0, directly you can write this step. Okay. So this is about your maxima and minima in 3 variables. So maxima and minima in 1 variable, which is having again 2 parts and which is seriously an important one, where I'm guessing for mechanical and civil. And EC since 2022, that means in these 2 years, no question was asked. So high chances are there for EC and electrical to come. And coming to maxima and minima in 2 variables, so we'll go with the same procedure, but we have to make sure about these 4 conditions. And maxima minima in 3 variables, so given subjected to the condition phi of xyz equal to 0. Right, so now let us say directly, you people, this was asked in 2016 for mechanical. Yeah. Just recollect, f of x is equals to x square minus 3x minus 4 upon x square plus 3x minus 4 is not continuous at. Now, when we were discussing about the continuity, just recollect the note point what we have written about the continuity. Right. So here in the green ink I have written. So f of x is equals to h of x by g of x is not continuous at the points where the denominator will become 0. Okay, whenever the denominator is becoming 0, at those points, the function is not continuous. Like say, here, what is the function that we have? F of x is equals to x square minus 3x minus 4 can be written as what? X minus 4 times of x plus 1 upon the denominator can be written as x plus 4 times of x minus 1. So no term is getting cancelled. So the function is not continuous for x plus 4 is equals to 0 or x minus 1 equal to 0. That means x equals to negative 4 and x is equals to 1. Right. So option B is the answer. Yeah, Farin, I said denominator should not be, it should be equal to 0. Right? So the denominator will be 0 for x equal to negative 4 and x equal to 1. Right. So here is the question which was, yeah.
So in this in the recent question, sir, what you have done, sir, you have to x plus 4 and x minus 1, sir. Sir, sir, in this type of questions, sir, which one I have to consider, sir? And in this question, sir, you have to x plus 4 and then x minus 1, sir, instead of x plus 1 and x minus 4. Why, sir?
No, just what are the, I have factorized x square minus 3x minus 4. How do we factorize this? This is x minus 4 into x plus 1. Yes?
Yes, sir.
And in the same way, the denominator x square plus 3x minus 4. So you can write it as x minus 1 into x plus 4. Right? I have factorized the numerator and as well as the denominator here.
Okay, sir.
So if h of x by g of x is there, the function is not continuous for what value? For g of x is equals to 0. Right?
Okay, understood, sir.
Okay.
I have to consider g of x in this kind of
Yeah,
questions.
not h of x.
Okay.
Right. So this question was asked in 2017 for electrical and it was asked for 2 marks. Say g of x is equals to negative x for x less than or equal to 1 and x plus 1 for x greater than 1 and f of x is equals to x minus 1 for x less than or equal to 0 and x square for x greater than 0. So he's asking about the composition of functions. F circle g of x is equals to f of g of x. Then the number of discontinuities of the composition of the function in the interval minus infinity to 0. So here the interval is being given. Now first let's analyze the function. Now let us say, so first let's discuss about f of x. Now what we are saying for f of x, say here I am having 0. Now when it is greater than 0, f of x is x square. And when it is lesser than 0, it is 1 negative x. So here I'm talking about f of x. And g of x is splitting at which point? G of x is splitting at 1. Now when it is greater than 1, it is x plus 1. And if it is lesser than 1, it is negative x. Right? So this is how f of x and g of x are given. Now, what is the interval that he is given? The interval is asking from negative infinity to 0. Right? Now, from negative infinity to 0, whether do we have any point where both the functions are changing? We don't have any point where both the functions are changing. Both are remaining as it is, right? From negative infinity to 0, f of x is 1 minus x. And from minus infinity to 0, g of x is negative x. Then the function f circle g of x is f of g of x in that interval. So what is g of x from minus infinity to 0? It is negative x. So that is f of minus x. And what is f of x? That is 1 minus x. So that is 1 minus of minus x. So which is 1 plus x. Now this function, does it have any point of discontinuity? It doesn't have any point of discontinuity. Why? Because in the denominator, we don't have any term. And moreover, the function is not at all changing from minus infinity to 0. So it doesn't have any discontinuities from negative infinity to 0. So the number of discontinuities are 0. Now, if let us say, if the function or if the interval, instead of negative infinity to 0, if the interval is 0 to positive infinity. Okay, now let us say if he is asking in this interval, then I need to check out the behavior of the function at which point? At 1. Why? Because in this interval, g of x is changing and f of x is remaining as it is. So I need to check out from 0 to 1 about the composition of the function and from 1 to infinity. So from 0 to 1, f circle g of x. That means f of g of x. Now what is g of x from 0 to 1? It is negative x. And what is f of x? That is x squared. So that is equals to positive x squared. And from 1 to infinity, what is g of x? So from 1 to infinity, g of x is x plus 1. Then what about f of x plus 1? That is x plus 1 whole square. So this is how the function is defined. Now at which point the function is changing? At 1. Now at 1 we are supposed to check out the left limit and as well as the right limit. Now if I'm checking out the left limit at 1, 1 minus. So 1 minus means it is coming in 0 to 1. 0 to 1 it is x square, which is 1. And limit extending to 1 plus. 1 plus means it is greater than 1. The function value is x plus 1 whole square. And if I substitute the limit, that is 2 square, which is 4. So the limit is not existing. So therefore, f circle g is not continuous at 1. So the number of discontinuities from 0 to infinity will be 1. Okay. So you have to be very careful with this interval. And again, there is a chance of asking instead of negative infinity to 0, the chances or the possibilities are negative infinity to 0, negative infinity to 1, and negative infinity to, 0, 1, negative infinity to positive infinity, and again from 0 to infinity. So these are 4 possible intervals that can be asked in the exam. So only one possibility he has from negative infinity to 0. So still 3 more possibilities are pending. So be careful how to analyze the function and how do we check about the points of discontinuities and all. Right. And this one, I think we have already discussed about the maxima and minima. Right. And now let us see the partial derivative. So this one was asked in GATE 2020 for EC. So what is f that is been given to us? So f is equals to e to the power 1 minus x cos y plus xz e to the power minus 1 by it is 1 plus y square, not 1 plus y, or let it be 1 plus 2y, whatever it is. So this is the function. Now the partial derivative with respect to x. So that means dou f by dou x. So I have to differentiate only x terms, treating other variables as constant. Now what is the derivative of e to the power? That is e to the power 1 minus x cos y into the inner term derivative. Derivative of 1 is 0. Derivative of x is 1. Cos y is constant. Plus z into e to the power minus 1 upon 1 plus 2y, or okay, y square. It is y square is a constant. Derivative of x, it is 1. Now I want the derivative, partial derivative at which point? 1, 0, e. So x is 1, y is 0, z is e. Now if I substitute it, that is e to the power 1 minus cos 0 is 1. 1 and to cos 0, that is minus 1. Plus z to the power negative 1. Sorry, the value of z is how much? Right. So the value of z, okay. Right. So the value of z is e into e to the power how much? Minus 1 upon 1 plus 0. And this is e power 0, which is 1, that is negative 1, plus e into e to the power negative 1. Right? So e into e power negative 1 is how much? Negative 1 plus positive 1. And the value is 0.
Sir, can you explain that step once again?
Which one, Srikar?
Sir, e power 1 minus 1 into minus 1 plus e to e
The
power
value of
minus
z is e, right?
Okay. Sir. Yes, sir.
E into e to the power minus 1 upon 1 plus the value of y is 0. So it will be e power negative 1.
Yes, sir.
So e into e power negative 1 is 1. So negative 1, positive 1, that is 0.
Yes, sir. Understood.
Okay. So option B is the right one. Right. Again, this one was asked for electrical in 2018. Let f of xy equals to ax square plus by square upon xy, where a and b are constants. If dou f by dou x is equals to dou f by dou y at x equals to 1 and y equals to 2, then the relation between a and b. So first, let's simplify this f. Now what I'll do is, I'll apply this x into f individually. That means what I'll be getting? Ax upon y plus by upon x. Now, dou f by dou x. So what is dou f by dou x? A upon y minus by upon x square. Derivative of 1 upon x is minus 1 by x square, is equals to dou f by dou y, partial derivative with respect to y. Derivative of 1 by y minus 1 by y square plus b by x. Now, what is the point he gave? X equal to 1 and y equal to 2. Now, substitute that point here. that is a by 1, sorry, a by 2 minus 2b by 1 square is equals to negative a by 4 plus b. Now bring it this side. A by 2 plus a by 4 is equals to 3b. And this will be how much? That will be 3a by 4 is equals to 3b, right? So 3 and 3 will get cancelled. The value of a is how much? 4b. Right? So option D is the right one. Right? Any doubts so far?
Sir, if in this, okay, sir, I understood, sir.
Okay.
Also, I want to know how this type of questions will also be asked in the exams, sir.
That's it. This is what the question was asked in GATE 2018.
I mean, what type of questions will I have based on this present question?
What kind of questions? Depending on present?
Sir, what I'm asking is now presently the question which I am seeing, sir.
Mhm.
What type of questions will I get based on this type of questions, sir? Where f of x y something given a b constant, so this
It all depends upon the partial derivatives. So there is a chance, like here, he didn't give any relation, right? In 2020, he didn't give any relation. He just gave the function and he's asking the partial derivative with respect to x at that point. So there's a chance, like the point can be changed, or there's a chance instead of with respect to x, he might say with respect to y, with respect to z. And in the same way here,
okay, sir.
other than x equal to 1, y equal to 2, he might ask a different point. Or he might ask in this way, like x into dou f by dou x plus y into dou f by dou y. Can you tell me what is this value? Yeah? Can anyone? Can anyone? Someone has asked me about the degree. So here, this f is a homogeneous function of degree 2 in the numerator. And in the denominator, again, it is a homogeneous function of degree 2. So f is a homogeneous function of degree how much? Of degree 0. So the value is 0. So the question can be asked in this way also. It all depends upon how you are understanding the question. So don't only stick to this part. So if he is asking about the partial derivative, in how many ways he can ask? You just analyze the question. Okay. So if a function is given in this way, so what are the possibilities that he can ask, which are related to the partial derivatives? He can ask the Euler's function also, that is x into dou f by dou x plus y into dou f by dou y. What is its value? And in 2022, there was a question, a homogeneous function was given, like xy into log of xy is given, and he gave the options. So which of the following is true? Like the options were x into dou f by dou x is equals to y into dou f by dou y, or the question is x into dou f by dou x is equals to minus y into dou f by dou y. So the options were given in this format. He just simply gave the function. If u is equals to xy into ln of xy, then which of the following is true? So it all depends, like how the model can be asked. Sure, Vikram, like if time permits, wow. Seriously, guys, I didn't look at the time. and we are running short of everything. Right, so no issues. In tomorrow's session, we'll continue with this. Okay, so in tomorrow's session, I'll be starting straight away, starting with the integrals, or we'll be starting with the Taylor series, and then about mean value theorem, only the statements of the mean value theorem. And tomorrow itself, I'll be starting with the linear algebra. Okay.